Hey there, I'm Ashwin Shanoy from S3CSCB Amrita Vishwavidyapitham. So let me get started off by adding a bit of context to what I'm going to talk about in this video. So in my 12th standard, I actually did this CPP project. And in that, I was able to actually show up a search result for flights between airports. So doing that actually made me curious about how search engines like Google could find out flights between, say, Kochi and Miami in about a click. So, and that result was actually showing the cheapest and fastest flights. So all that made me really curious, and that's actually what motivated me to make this video. So here I've opened a map of top 50 busiest international airports. So say we wanted to go from Mumbai to New York City, we could do that a lot of ways. So maybe we could fly transatlantic via London, or we could fly over the Pacific Ocean via Tokyo. Maybe there is a direct flight. And of course, depending on the airline's hub, there are a lot of other possibilities as well. So how does Google actually find the cheapest and the fastest routes among, like, say, there are thousands of prominent airports across the world, and the possibilities are like a lot of them. So how do Google actually find out the cheapest and the fastest way across this, and that too in a couple of seconds? So we could actually model, and I could use this analogy, or this is a very good intuition for us to learn about graphs. So we could actually consider each of these international airports as nodes in graphs. So Mumbai is a node, Dubai is a node, New York City is a node. So basically nodes are junctions. So nodes equal to junctions. And in aviation terminology, we sometimes refer to these as hubs. So Dubai, for example, is the hub of Emirates. So if you take an Emirates flight from New York City to Mumbai, you go from New York City, layover at Dubai, you change flights, I mean the aircraft, of course, and then go fly on to Mumbai. So Dubai acts as a junction, maybe for other flights coming from Frankfurt or from other passengers coming from London. For all these people to go to Mumbai, that's kind of a hub, and that's why like it's a junction. And and the next thing we might want to know and want to discuss in this data structure is these routes. So what are they called? So edges are basically the path or the route between two nodes. And you might have noticed already that it's not the same flying from Mumbai to Dubai and Dubai to New York City, for instance, because the distance is totally going to be different. The duration of the flight is going to be different. Maybe we need to take a different type of aircraft for flying this long, and because of all these factors, the cost or the fare of the flight is going to be different. So you might understand that these edges require kind of a property or a kind of their own attributes, because that's really going to be important, at least in this kind of data. So we call them weights. So there are going to be weights of edges. The next thing one might be interested in knowing is that where can I fly from Dubai? Or what are the destinations that are possible from Dubai? So in graph terminology, we call that adjacency list of Dubai. So for instance, in this map, we can see the adjacency of Dubai is New York City, London, Frankfurt, and Mumbai. So the adjacency list basically says where all you can go from this particular airport, what are the possible paths you can take from that particular node, and that is basically the destinations possible. That is what it says, destinations possible. And relationship between two nodes, or in this case airports, can be either both ways or just one way. So in graph terminology, we refer to them as directed graphs and undirected graph, directed and undirected graphs. So in this case, it's going to be an. Now that we have had some introduction about graphs and got some intuition about it connecting with flight, let's get into this problem. Say I wanted to go from Kochi to Miami, and I would have these two questions in my mind. The first one obviously would be, how do I get there? How do I get there? So this is actually like what is the path I need to take, the path finding thing. So there is always going to be different paths to go to Miami. So there are going to be several possibilities for me to take on. Now, the second question, because it's not always going to be like I just need to get there, because I might be interested in going there fast or flying there cheap. So, how cheap or fast I can get there? I can get there. Uh, and if you see, there are only going to be a few possibilities because many of them are going to be eliminated. And you might have already noticed, in the first case, we really don't need to see, no need to see weights, no need to see weights because we simply need to find whether these airports are connected and it's like a puzzle solving. And in the second case, we really need to consider weights. So these are the two questions we need to solve. So the first question, now let's try answering these questions. How do I get there? That's a fairly simple question, and for that you just need to draw out a line from Kochi to Miami through any one of these. But let's get into the trickier question. How cheap can I get there? That's a bit complex. And let's consider Bangalore. So I don't think Bangalore will take us any cheap because it's finally leading to Bombay or Delhi. So we can rule out that possibility. We can now see which one of Delhi, Dubai, or Bombay will take us cheaper to Miami. So let's consider the Delhi. Then it's about 6,000 to reach Delhi, then 45,000. I don't think JFK is going to be cheaper. Let's go to Dubai and then reach Miami. It's going to cost 75K for that. Now let me consider the direct flight to Dubai. That's going to be 15K, and 50,000 more means it's going to cost 65K to reach Miami in that. Now, I guess that's the fastest way because it's a one-stop flight. Now let's see if flying through Bombay will save us any cost. So reaching Bombay it will cost me 3,000, and then flying to Dubai 12,000. That's 15,000, and 50,000 more. It's again going to be 65K. So the cheapest flight I could take is going to be 65K, and if I look into the fastest one, I guess it's the Dubai via Dubai flight, which is going to be the fastest one. Now, this was fairly simple for us to solve manually. Now let's consider how we can solve this problem using an algorithm. Now let's try solving this problem using an algorithm. So I opened up a slideshow from MIT and we are going to discuss Dijkstra's algorithm. I don't know exactly how it's pronounced. Dijkstra's algorithm maybe. Yeah. So this algorithm was designed by Djikstra. So he's a famous computer scientist from Netherlands, and I guess he made this algorithm in 1950s, and he received the AM Turing Award, which is widely considered the most prestigious award in computer science back in 1972. So this guy made that, and let's see what actually this algorithm will do. So the problem of finding shortest path from a source vertex to all other vertices in the graph. So that is what Distra's algorithm could actually solve. And now let's see, we have some preconditions before we could actually apply this algorithm. So it can be either directed or undirected graph. So that's not really a condition, but all edges must have non-negative weights, and graphs must be connected. So now let's look into the pseudocode of Distra's algorithm and try to figure out the answer for the question we already discussed earlier. So what we do is we create a table like this, and we list out course from COK because we are only interested about what are the costs to reach from COK. And so we create a kind of a table here, and see the distance to source vertex is 0. Okay, the vertex, I never talked about vertex. So vertices are just nodes. So vertex is just another terminology for nodes. So nodes are basically junctions, by the way. And so the distance to source vertex is 0. That means that the distance is just another weight. So in this case we are dealing with cost. So the cost to the source vertex is going to be 0.
obviously, because we know to travel from Kochi to Kochi it's not going to cost anything as far as obvious. So that's the first line of the pseudocode. And then what we do is that we set all other costs initially as infinity. We'll get back why that is infinitely particularly later, but yeah, we set that to infinity because we don't know whether this could actually, what is the cost, because if there is no flight it's going to cost infinity. That's kind of an assumption we make initially. So we set all other costs to be infinity, and this is probably stored as an array somewhere. uh, then what we do is that we create a list of visited nodes or visited airports, for instance, in this case. So this is going to be initially empty because we didn't iterate to any of these. So next what we are going to do is that we are going to create another queue. So in this queue we will queue all the airports, so COK, BLR, and so on. And what we do in this algorithm, so we have reached here, and what we do in this algorithm is that while this queue is not empty, we try to dequeue each of these airports. So how do we start with dequeuing things? So what we do is that we look for the adjacency list of COK, and we find that we find the node which has the least with the edge actually, which has the least cost. So it's going to be the Bangalore edge. So what we do is that we go into that, and that is where we reach. I mean, we reached here in the algorithm now, and we add Bangalore to the list of visited, and obviously dequeue from it, dequeue it from the queue. And then what we do is that if we find that we obviously update this now, so we just update this now with 2000. So the cost for getting to Bangalore from COK is going to be 2000. The next and the most cleverest part about this algorithm is that now we look into the adjacency list of each of the neighbors of, or the adjacency list of Bangalore. So what we do is that, so from Bangalore you can get to Delhi for 7,000, and I never wrote for Bombay. Say we reach at 7,000 again for Bombay. I don't know, or maybe 8,000. So what we do now is that let's, okay, I didn't write many. So Delhi to Bombay it's going to cost 5,000 say. And what we do now is that we look whether this cost is gonna be less. So what we do is that 2000 is the cost to get from Kochi to Bangalore, and then to fly to Delhi it's going to cost another 7,000. So this is going to be a total affair of 9,000 rupees. So we check whether is this less than the cost we know to fly from Kochi to Delhi. So now it is set to infinity. So it's going to be obviously less than infinity. So the best flight we so far know to fly from Kochi to Delhi, the cheapest one right now is 9,000. So that's via BLR. So we also have this particular thing, you can call it predecessor, or and this actually shows via which airport. So this is via BLR, so we can have this particular array as well. So then we go to its next next particular adjacent neighbor. So what we do is we can find out Bombay. Now it's going to be 10,000 because we are adding up the cost to reach Bangalore and then the cost to reach to Bombay. So it's going to be 10,000 right now. That's what we know so far. And then I don't think Bangalore has any other things. And now what we do is we look for the second best thing that start from Kochi. Looking back to the adjacency list of Kochi, we look for the next cost efficient route. So if you look at it, the next cost efficient will be to Bombay, flying to Bombay. So we dequeue this from here and we add Bombay to the visited list. So what I do is I go to Bombay and then I just see to reach Bombay. Now I just need 3,000 rupees. So this particular condition is gonna be be affecting it. So the cost to reach Bombay now is just 3,000. And so if the cost is getting reduced, we update this particular table. So the cheapest cost we know now for sure is 3000 to reach Bombay, and earlier this was through BLR, but now it's a direct flight, so we just empty this out. And next, what we do is that we look into the adjacency list of Bombay once again. So from Bombay to reach DXB, we take out the 12,000. So we know for sure that we can reach from Kochi to Dubai for 15,000 via Bombay. And what we because this was going to be less than infinity, that's why we could update it. Now we could reach to Delhi by another 5,000 rupees, so it's going to be 3,000 plus 5,000. But yeah, that's actually cheaper way to reach Delhi, if you ask me, so compared to the Bangalore one, because this one just cost 8,000 rupees. So I can replace it by saying 8,000, and this is gonna be via Bombay now. And next thing, so we are looking for all the adjacency list. We can see we can reach Bangalore adding 8,000 plus 3,000, that is gonna be 11,000, but it is obviously greater than the 2,000 what we discussed earlier, so we don't need to update this. And uh, that's it, I guess. So we don't fly anywhere from Bombay again from there. So we added it here, we dequeued it from the queue. Now we look for the next particular neighbor of Kochi in its adjacency list. So the next cheapest one would be to fly to Delhi. So flight to Delhi is itself 6,000 rupees. So currently we know 8,000 is the cost. So we could remove this now and replace it with 6,000. And that's going to be a direct flight, so there is not going to be anything. So, and what we do is that we add this particular DEL airport into the visited one and dequeue it from here. And obviously we initially dequeued COK from it, and it's going to be finally added up here, because we are coming back to that loop once again. And now what we do is that we find out once again what are the costs to reach out for different nodes. So let's see, I don't think flying back to Bombay or BLR is going to helpful, so I'm not going to discuss that again here. So yeah, usually we loop through all its adjacent list, but now let's go forward and see. So to reach Dubai from there, it's going to cost 20,000 more. So 20,000 plus is 26,000. It's not going to replace the 15,000 we have here. So next thing is to fly to JFK. So it's going to cost 45,000. So that's for sure less than infinity. So 45,000 via Bombay. So we now have a cost for flying from Kochi to JFK. That's going to be 45,000 plus 6,000. Sorry for the mistake. So 51,000. And now we don't then we have we couldn't update anything more. Yeah, that's it. So then we finally have the DXB thing. So the last neighbor of Kochi to be discussed. So it's gonna cost 15,000, and maybe it's the same price from Bombay, but we can optionally remove this predecessor because we don't need. We can take a direct flight now, and the adjacency list of this particular DXP is going to be interesting for us. So what we do now is that we look into the neighbors of this particular airport. So what we do is from DXB, what are its neighbors? So it just goes to Miami. So uh, the cost to reach Miami now, finally we got it as 50,000 plus 15,000. It's gonna be 65,000 via DXB. That's the cheapest fare we right now have, and that therefore we could add DXB back to this and dequeue it from here. Now if you see, there will be one thing left in the queue, that is JFK, and we can try to dequeue this out, and we find out that to fly from JFK to Maya via JFK, it's going to be reaching JFK will cost us 51,000, and then again 30,000, it will be about 91,000. So we couldn't replace anything from this list using JFK, so we will simply add that to the visitor list and dequeue this. So what happens is that this queue gets empty and this gets filled with all the airports. So once we are done with that, we could actually find out which is the cheapest among this particular thing to reach Maya. So we have the idea of this, so we could refer back to this, and we can find that it's the cheapest way to reach Dubai is through this particular flight from Kochi to Dubai and then to Miami. So we could find which is the cheapest one. So this is what Djikra's algorithm is. So in recap, I could say that we initially set all the source vertices to 0, all the source nodes to 0, the cost to all source nodes as 0. And then we set all the costs to all other airports as infinity. And then we create a list of all visitor airports, and initially that's going to be empty, and then we create a queue which contains all these airports, and then while we kind of try to dequeue this particular queue, and while it's not empty we kind of do that, and what we do is that we find the element which has the least cost among and what for that what we do is that we look into the adjacency list of the source airport Kochi, and then we figured out Bangalore, and we just go on from there. And then what we do is that we need to add this to the visitor vertices and dequeue it from the queue. And then what we do is that for each of its neighbors we find out the cost that would have been originally from Kochi. So what we do is that we add up the cost to reach that particular node from Kochi, and then forward to the adjacent neighbor of that particular airport. And then if it is less than what we already know the cost to reach there from Kochi, we update it in this table, or otherwise just leave it. And then maybe we'll also have this predecessor list where we add this particular node via which we could reach there. And finally we'll have this table which will show us the cheapest of fares to all these airports from Kochi. And we were interested about knowing the fare to Miami, and we could just go to that particular ID and we can find that it's 65,000. So that's how you find it using Djikra's algorithm. So that's all for this video. Thank you and hope this video helped you. See you again. Bye.